Right, so what we're looking here is at the structure of the Bowman's capsule. Bowman's capsule. Right, so what you have is, let's do it that way. Right, so you have, let's do it this way. So you have that's the Bowman's capsule. So what happens is fluid's going to flow down here, or the filter it. So let's get rid of them. Right, now what you do is around the Bowman's capsule you have a layer of cells, a single layer. So let's draw those. So what you have here is, so these are your nuclei. These are the cells of the Bowman's capsule. So next what happens is you've got a capillary. It comes in and it goes out. And remember we said this is larger and leaving it smaller, so you get a difference in pressure. There's a lot of pressure in here, and at the same time what happens is this splits up into lots of little capillaries, so it increases the pressure even more. So you've got lots of little capillaries going around. So what's happening is blood is flowing in here, it splits up, some goes down here, some goes down here, some goes down here, and because of that the pressure increases and things start flowing out of the blood into the Bowman's capsule. So let's label this here. That's your capillary. That's coming in, and when it splits up, this, let's change colour on that. So this ball of capillaries here is called the glomerulus. And like we said, what happens is, let's get another colour. When the filtrate comes through, this here is the start of the first coiled tubule. I'm just going to write tubule for now. So it's the first coiled tubule. So that's the structure of the Bowman's capsule. Now if we zoom in, so let me just, right, if we just zoom in, just say into a section here. Right, so what's going to happen is, can we get away with that? Yes we can. Right, okay. So let's get this right. You've got your Bowman's capsule. No, let's not draw it like that. Let's draw the same color. So there's your Bowman's capsule. That's that bit there. So that is there. Right, then you've got your capillary. Let's use red. So you've got your capillary wall, which is made up of little cells, and it's permeable to allow things to flow in and out. So that's that bit there. That's this wall here. Right, in between them you've got a basement layer. And they might ask you, I've not seen this sort of question, so it's good to be familiar with the structure. Right, so we've got, let's label all these up. So that there is the capillary wall, 1 cell thick, short diffusion distance. That there's the Bowman's capsule wall. Again, single cell, and it allows things to diffuse through. And this one here is called the where should we put that? Put that here. It's called the basement layer. It's called the basement layer, that there. Right, so this is what happens. You've got a red blood cell. I know it looks green. So under pressure, that'll try to get through, but it can't, it's too big. What you do get through there is things coming through here. So what you're going to do is you're going to get water managed to get through. You've got like your ions, like your sodium and your phosphate, and you've got other small molecules like urea, which we need to get rid of, and glucose manages to get through, but that will get reabsorbed. Okay, so this is what's going on in this section here, Right, let's quickly go through that in one foul swoop. Okay, so what you have is the Bowman's capsule here. That's the Bowman's capsule. That is the start of the tubule, and you've got a capillary coming in. It breaks up into a glomerulus. You get ultrafiltration going on here. Things move out of the blood into the Bowman's capsule. Right, if we were to zoom in on this little bit, there's your Bowman's capsule cells, or the wall. It's got little gaps in to allow particles to diffuse through. There's your capillary wall. It's got gaps in to allow things to diffuse through. There's your red blood cell and your white blood cell, and it's trying to get through, but it can't because this gap isn't big enough. But you get smaller molecules coming through, like water, ions, urea and glucose. Some of these will get absorbed back in, like the water, some of the ions maybe, and glucose. Glucose is too valuable to lose from the body. You've got a middle layer here. It's called the basement layer. It's not made of cells, but it's permeable. It means it allows things through. Right, I think that's all you need to know for the ultrafiltration process.